Long before the theory of gravity was a glimmer in Isaac Newton's imagination, objects fall or rise based on their relative density to the medium surrounding them.
And what causes it? Gravity. If there was no gravity, the fluids in a density tower mix.
Apples fall because they are denser than the air, while helium balloons rise because they are lighter. No gravity necessary. This is why raindrops fall down through the air, and air bubbles rise up through water.
In the water, air bubbles do rise up. Because of gravity. I know this will be mind-frying, but the bubble is buoyed up by the water. And these International Space Station bubbles do not go up. They go everywhere.
If Newton's apple had landed in a puddle instead of on his head,
no, it never landed on his head.
He would have seen the apple only fell through the air because it was denser than the air, but then floated on top of the water because it was less dense than water.
Objects should fall upwards, as that's where the less dense medium is. And also, why is water stuck to the imaginary pizza Earth?
We can also prove this fact of relative density by filling a plastic balloon with approximately half helium and half air. Since helium is lighter than the oxygen, nitrogen, and other gases that compose the air around us, filling a balloon with just the right amount of helium to compensate for and balance out the density of the plastic results in a gravity-defying, levitating balloon at equilibrium that neither rises nor falls.
It isn't defied by gravity. Gravity is still attracting it. The balloon is only pushed upwards because of gravity. A medium of a particular weight allows the object to pass through it if it's lighter than the medium, even though the acceleration is the same. Mind-frying.
Skeptics often ask, if gravity doesn't exist, and objects simply fall down because they are denser than the medium surrounding them, why do objects of varying masses all fall at the same rate? If there is no gravity, why does a helium balloon fall down in a vacuum chamber? And without gravity, why exactly do things fall downwards when dropped, rather than upwards or sideways? To begin with, a feather and an anvil will both fall at different rates because one is radically denser than the medium surrounding.
They still fall at the same rate in a vacuum,
air, while the other is not. Imagine a dandelion seed and a brick, or a piece of paper and a boulder. These examples and many others fall at drastically different rates.
I did this experiment one time. You drop a paper. It falls slowly due to air resistance. You then compress the paper. Even though it has the same mass, same density, it takes up a different volume. Same weight, though, but air resistance is this time much more negligible, as it falls faster.
Debunking the supposed uniform speed of acceleration due to gravity of 9.81 meters per second squared. This phenomenon would be more accurately titled the maximum acceleration towards density equal. In a vacuum chamber, the medium of air is removed completely, so all objects, including a feather and a bowling ball, will fall at this same maximum rate. By removing the medium from the equation altogether, all objects, including a helium balloon, will fall to the ground simultaneously. Without any medium to move through, the fall rate of all objects is indeed equal, but this has nothing to do with some mythical attractive pulling force, and everything to do with the fact that the density of the surrounding medium has been reduced to zero. Therefore, in reality, since a feather, bowling ball, or anything else inside a vacuum chamber is infinitely denser than empty space, which has a density of zero, it all falls at the same rate of 9.81 meters per second squared, which is actually the constant fall rate of matter in empty space, or maximum acceleration towards density equilibrium, but not a uniform speed of acceleration due to gravity.
You explained nothing about what causes objects to fall. You only said that they just fall.
As for why objects fall downwards when dropped, rather than upwards or sideways, firstly, there is a pressure gradient formed by the amount of stacked air, water, and land over you in a column, which increases the pressure, weight, and density the farther down you go.
No. Atmospheric pressure is compressive. It won't make an object fall in a singular direction. And why are these mediums stacked on top of each other in the first place?
And that defines direction. Secondly, helium balloons fall up, not down, proving there is no downward directional bias.
You said something about atmospheric pressure. And helium balloons are again lighter than the surrounding medium. Gravity displaces lighter matter upwards, while displacing heavier matter towards it.
This is all perfectly explained by the natural physics of density and buoyancy, which was well known and understood long before Sir Newton renamed and remodeled it to fit with his heliocentric theory of the cosmos.